Hey everybody, this is Larry. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about today's farm. It is day 18 of the July Leetcode Daily Challenge, and the farm is number of submatrices that sum to target. I hope everyone had a great weekend. I'm back to New York, as you can see in the background. Um, it was a very long bus ride, so I'm very tired though. I passed out because I ate a lot of food, so I'm okay now. So let's go. Let's see what's today's problem. All right, it's a hard one, so hopefully we'll do well. We'll do okay. Given a matrix and target, return the number of non-empty submatrices that sum to target. A submatrix x. Okay. Is it all one and zeros, or is it just this? Oh no, it's just this example, which is okay. Okay. So for problems like this, I mean, this is hard, for sure. I don't have an off my head solution yet, so we'll do it together. Will be fun. If it's a little bit slow, watch it on 2x or whatever. Okay. So the first thing I would try to do is think about what I would do in 1D, right? This is a 2D problem, I know, and that is some part of the difficulty. The first thing I would do though is still think about 1D and solving that first, and knowing what to do in that case will at least give you some basis of an attack, maybe. Not always true depending on how the structure is, but this one seems like, and if nothing else, that is going to be one of your inputs anyway, right? Like if you have a 1 by x array, then 1 by n array or whatever, that's going to happen, right? Okay. So if you're given that, let's say you have a number of sub arrays that sum to target, well, that's a waste. I think I wouldn't say I want to say it's standard, but I don't think it's actually standard. I think it's tricky. It's almost like a prefix sum type thing, but it's something that, at least for competitive programming, and I don't think that's the case for interview quite yet, but I could be a little bit wrong on that one. But it is something that people have gotten, and some of that is making sure you do the understanding of that problem, right? Let me just write it out so people know what I'm talking about. The understanding is easy, or is the focus that I would have, because I think you look at the code and it's like three lines of code. There's a hash table, there's a for loop, there's a statement, there's an if statement, there's an add, there's a return, and then you're done, right? For this problem, something like that. And it's very tempting to say that, okay, look, the code is 6 lines of code. How hard can it be, right? This is an easy problem. Some of it maybe because it's 6 lines of code or whatever, people might just like, have some memories, memorize it without memorizing it. Or maybe another way of saying it is not truly understanding it, right? And so, so definitely make sure you understand that. I think that's step 1. And then step 2 is then now what, right? Let's say we do understand the 1D one, the subarrays one. How do we extend it to 2D, right? Well, I guess that's the same idea, right? You have the number of all the things that are to the. So basically, in the 1D version, you're given almost like a pointer, right? I wouldn't call it a sliding window, but like a pointer of this is the current thing, and the current cell in that case would be like, okay, this is the right side of the 1D array. How many left sides are there, right? So then a corollary to that in 2D would be that this is the bottom right. How many how many upper left corners are there, right? I think that's the way that I would start approaching that. And then the question is, can I do that in a good way? because the problem here is that every time you add a new row, you almost have to reset it. Like if you think about this, okay, actually, let me just draw it out. Hang on. Now that especially now that I'm back in New York, I got my drawing thing. I have to think it through a little bit. Or like, I feel like there are a couple ways to do it, but I have to maybe take a look at the constraints as well. Let's see. Think about this for a second. I mean, 100 cube would be good enough, so that's definitely a thing. But basically, the idea here is that. Wait, I put it on screen. I did not. Good catch this time, a little bit. But basically, the idea is that okay, let's say you have, you have some cell, right? And as we said, don't know how that line drew into place, but this is weird. Right, let's say we have someone like this, and then now we're here, right? Or let's say we have this cell and we're moving to this cell. Oh, so then how does that work? I don't know how you would work it without like resetting everything, oops, how did that happen? Because if you're moving from say this cell and into this cell, you just add kind of all the numbers here, but because you're trying to find upper left that is in this section, right? And then now you're trying to add it to this section to find target. I think I know how now. And some of this is the constraints, right? Because yeah, I mean, I think we can just do it that way. Let's see, because each cell. Wait, can we do it that way? I think. Why is this so weird? It's not letting me erase this now, but okay, fine. But then I think another way of doing it, and this is a little bit about abusing the constraints, is that now we can just do it for every 2 rows or something like this. Because here, then now this is going to be. Let's say we pick any 2 rows. What does that mean, right? And let's say we have some sort of prefix sum that allow us to almost brute force. Basically, one way that we can do is that now let's say we have these 2 rows, and they'll be going to be all square rows, or I'll choose 2 rows. Basically, what you do now is compress this with prefix sum into just 1D version of what we did before, and then you could do the O of N or O of C algorithm, and this one, and here is basically this cell, for example, is the sum of these 3 cells. Here is the sum of these 3 cells, right? And then now it becomes the 1D problem. And if you do this brute force on the left, as in you try every possibility of R's, this is going to be R square or R choose 2, depending on how you want to say it. I mean, R choose 2 is O of R square, number of rows, and for each of these, you do O of C work, and that will be. Why is this drawing thing so lagging today? O of R squared times C, which is going to be 100 cubed, which is fast enough. I think that's what I'm going to start doing then. Hopefully this makes sense as an explanation, but yeah, I think that makes sense though, for me anyway. Definitely if you, yeah, I think the key part is still doing the 1D version, which is this stuff, and then once you understand that stuff, then it just becomes brute force in a way. Okay. Yeah. Okay. Let's do I need a prefix window? I guess so. Well, we don't yeah, we don't need a full prefix. what we need is almost like a vertical prefix, right? Yeah. Is my paint thing still up? Okay, no. Yeah, I think we just need a vertical prefix because if you look, let me bring the drawing back up for a second. Because if you look at this, okay, so we look at the first three columns and maybe that's a bad example. But let's say we have, let me change the color really quick. Let's say we look at, say, this row and this row, right? Well, every time you move to the right, you're gonna just, add like, you're gonna add something like this row, which you can calculate from the vertical prefix. You don't need the actual matrix prefix, right? So okay, so I think we can do it from that instead. Instead of a 2D prefix, we can do a column-wise prefix. Yeah. And okay, so the way that we're going to do it, it's going to be O of R squared times C. And why I'm pointing this out a little bit early is because now if R is bigger than C, we can actually rotate the matrix. So let's do that, right? What I mean by that is just not rotate. Is that the right word? I guess we could flip the RC, and then that'll be slightly faster in general. So let's do that. Yeah, the way that I'm going to do it is just this. C, then yeah, new matrix is equal to. I think there's like a one-liner for this, but I never remember it, so maybe that's fine. Is this all times C? Yeah. Okay, we want to flip it. So then for nope. Return self.num sub matrix sum target of new matrix and target, right? Okay, so this is just to take advantage of R squared times C. Well, it's not necessary. It's definitely a premature optimization. Let's take advantage. But I think like I just feel like doing it today. Some days, and obviously this is not a contest, so it doesn't matter. But yeah, at least timing wise. Okay, and then now what? Okay, so then let's create a vertical prefix. Yeah, so we want a prefix for each column. So yeah, so you have something like +1 because we want the first row to be zeros, so that's fine. And then now, yeah, prefix of ij is equal to this is actually +1 is equal to plus matrix of ij. Again, this is only the vertical component, so if you are looking at it now, it's not the full 2D one because we don't need the full 2D one. That's the beauty of solving problems, maybe, is that you do what you need, right? Okay. And then now we do the 1D algorithm given every row, right? So for I in range of R, let's say I1 maybe, and for J, for I2 in range of from I1 plus to R. Yeah. Okay. And then now we do the thing that we did from the 1D one. We just have to make sure that we're sliding okay. I just say counts is equal to start with 0 is equal to 1 being the, actually I guess technically we have the extra prefix, but no, I mean I think this is fine. Yeah, basically this is the no array, right? Also we have to keep track of total for just overall total. Yeah, I was just trying to see what's the maximum. I guess given 10 cube, or yeah, I think 10 cube is probably the maximum, maybe, or close to it. Is that true? Basically, if they're all zeros, then for each cell, you would have the summation of n squared. So it's like n to the fourth, maybe. So 100 to the fourth. I guess that's a billion. So that'll be fitting into an int. I know that that's a really bad upper. Anyway, so it should be okay. Okay. And now for j in range of c, right? Then here, oh, we do current is 0, 0. Maybe we have that. This is the prefix on the from the left going, going to the right. And then now we want to add the number between so this is going to be I2 of j minus prefix of, we want it to be I1 inclusive. Actually, because of the +1, this is actually this minus this, I believe. And then, so that's the current thing of that's the current prefix from the beginning to this cell. So then now we have the current thing of the matrix. And then to find target, right? So you have current, let's see, what are we trying to find? I'm trying to write out the formula, right? So target is going to be, so the current, we're trying to find a subset of it that we use, is going to be equal to target plus some number x, right? Hopefully this part makes sense. And then, yeah, I mean, maybe I'll draw it out very quickly because I want to, it makes sense in my mind actually, but I want to make sure that it also makes sense for people at home. But basically what I'm doing is that this is the 1D version now. So let's just pretend it's a 1D version. The idea is that now, oh, yikes. I'm using the mouse because I'm lazy to take the thing out, but it's kind of bad. But let's say this is current, and this current means this is the sum of here, right? And then here, we're trying to figure out some subset where this is the target total. So that means that this is the x that we're trying to find, or this is just the x that I'm parameterizing. Oh my God, I can't do English today. But yeah, so that means that the target is the middle chunk of x is the prefix that we're trying to remove, and then the current is the total, right? So you have this. So then now we're trying to find counts of, because we know target, we know current, so we can minus target on both sides, and then so we're searching for this thing, right? So counts of this thing, and then total we can increment. This is, the indentation is all off, but yeah. And of course, the way you should do it is to make sure that it is in counts. The reason being that otherwise it creates an entry by default. I think this is rightish. Let's give it a spin. No, I'm really wrong. Well, I got one case right, but did I get this formula wrong? Usually, I mean, not usually, but the reason why I take a lot of time on this is because I do make this mistake a lot, but let's see. Okay, so the target is 0. Well, this one is just really wrong. Maybe I have an off by 1 on somewhere, because this one should be even just like by itself, right? So oh, I'm just being dumb, am I? I forgot to I forgot to increment current. I mean, it might not be the only thing that's wrong, but oh, I'm just also lazy. Huh? I usually write that counter. I don't. That's why I a little bit sloppy today, to be honest. That's why I did the in thing. Otherwise, that doesn't make sense. Okay, oops. Okay, so I just forgot. I just forgot to increment it, even though I was talking about it. And this is, if you have any confusion here, like I said, this is the 1D version of the problem, so I don't think I did anything new here. And apparently I made a lot of mistakes in the past. Let's see if I got it okay the first time. Yes! You always want to do slightly better than you did previously. And today I did it from scratch, pretty okay, 20 minutes. Of course I did a lot of talking and explaining, so I'm pretty happy and proud of this. Okay, that's pretty much all I have for this one. Let me know what you think. I hope y'all have a great, rest of the week. Yeah, stay good, stay healthy, take your mental health. I'll see y'all later and take care. Bye bye.